Hey, Charlie Pyatt here, and welcome back for Season 2. First off, I wanted to give a big thanks for all the interest in the AR/VR headset project I did last round. I didn't expect it to get so much attention, and it was really amazing to see all the support. This season I wanted to change things up a little and do a set of custom-formed wireless earbuds. I'm going to make these from a casting of my ear to get the perfect fit. Making these will require a bunch of different techniques and technologies, from 3D scanning, 3D printing, mold making, and casting. I'm going to try electroplating 3D prints for the first time as well, so we'll see how that goes too. During this build process, I'm going to do some tricks I haven't really seen documented before, so it should be a pretty fun ride. In any case, let's get to it. So this project's going to be built a little bit like a custom in-ear monitor, or CIEM. CIEMs are usually used by stage musicians or studio broadcasters. So they're usually made by taking a casting of a musician's ear and then 3D scanning that casting back into the computer. CAD data can then be printed out to make a perfect fitting earpiece. The setup helps a lot with isolating ambient sound from the musician so they can hear what they're playing accurately. Because these are custom made for a wearer's ear, they obviously help a lot with comfort and preventing pressure points that you usually find with other in-ear audio devices too. Custom in-ears are almost always wired and have very high quality audio components inside. For this project, I don't really care about getting audiophile quality playback. I'm more interested in just the fit aspect of everything. I've had the same issue with almost every earbud model I've tried, where if I just wear it for long enough, it tends to work itself out of my ear. So with that in mind, the plan here is just to make a custom in-ear enclosure and then pack the internals with an off-the-shelf earbud. Probably something with just Bluetooth and noise-canceling features would be nice. So most custom in-ears fit pretty far into the ear canal and then rest against the concha of the ear to keep them fixed in place. This is great for ambient noise isolation, but I really don't want my design running that deeply into my ear canal. Instead, I'm going to extend my design up and have it hook underneath the upper part of my ear. This should keep it plenty stable on my ear and make it a little bit more comfortable for me personally. This should make a pretty unique design that I really haven't seen done anywhere else before. I hope there's not a reason for that, but we'll just have to see. So with a very general size and scope figured out, the next step is to make a silicone casting of my ear. For this next step, I'm not going to go too far into the details. You should really always go to a professional audiologist to get any sort of casting like this done. You can permanently damage your hearing if you don't. With that said, here are my silicone castings of my outer ear. They generally came out okay, or at least good enough for what I need them for. Next step will be to 3D scan these in, so I'll have the geometry to build my custom in-ear enclosure around. The 3D scanner I'm using is a RevoPoint Mini. The Mini has a pretty good resolution and a big enough boundary box to fit these castings into. The scanner itself is pretty compact, so setting this whole thing up is super quick. You can basically just drop it on the turntable and then a few minutes for the left and another few minutes for the right, and the scanning's all done. So over here on the software side, you can see the 3D scan coming in. See the point cloud data being generated as the model spins around on the turntable. All those point cloud frames are then realigned, and everything's coming in looking pretty good. You can see there's a couple little gaps under some of the overhangs where the scanner couldn't see. I'm going to go back in and do a couple more scans of the same model just to make sure I'm getting full coverage of everything. I can then remerge those back together and get my finished mesh. So I have my completed mesh right here, and I've extruded out a little bit and capped it off to make a solid manifold. From here I'm going to do some Boolean operations to this mesh. That's where I just draw some larger shapes and then subtract them from this base model. That'll give me a finished form that'll be closer to what the final object will be. I don't really want to get perfect right now, I'm just trying to get something in the ballpark to gauge size and shape. And yeah, you can see here I've cut that larger object down and retopologized it to make a finished printable object. This is going to be just sort of a test model that I can put in my ear and tell how it feels. This will also give me an idea of how much space I have to work with when I start packing in the electronics and other components. So yeah, you can see I've printed those out. I basically took an average of the left and right scans and made sort of a middle ground model that I can just mirror left and right. That way I can just 3D model one of these and then mirror it over to get the other side. It's kind of a hack, but the deviation between my left and right ear scans was pretty close, so I'm really not sacrificing too much on the fit side for this. So now that I have my dummy test prints all ready to go, it's time to put them in my ear and see how they feel. These actually feel great. I'm really not noticing that they're the same model mirrored left and right, so I'll take that. So now that I know my scan data is pretty solid, I can move on to modeling a more complete concept and explore color, material, and finish. So now back inside Rhino, I've modeled out a more complete concept. The idea with this is to co-mold an electroplated lattice inside silicone. So what's going to happen is I'm going to electroplate that little inner structure and then hold it in a mold and inject silicone around everything. I'll go more into the details of how I'm going to do that later, but for now I'm just trying to get a general sense of the look and feel. I'm really excited about experimenting with this concept. I should give the product really rigid mounting points for all my audio components, but then add a nice soft gel around the entire design. It should make it super comfortable and give it a really unique look. I exported the geometry out of Rhino and brought it into Blender to get some better renderings out. I think this gives a better idea of how that opaque silicone might sort of diffuse the lattice structure underneath it. Again, I think it's going to be a really striking combination to mix that copper electroplating with silicone opaque overlay. This is one of those projects where you're not going to know how it'll come out until you finish it, so I'm really excited to keep moving with the process. I'm at the point where I won't be able to do any more design development until I choose my donor earbuds for this build. I'm going to need to find an off-the-shelf set of Bluetooth earbuds, take the internals out, and reinstall them in my custom enclosure. The audio hardware I select is going to have a big impact on the dimension and overall look of my final design, so it's important that I get that locked down sooner rather than later. Originally, I was going to use the Apple AirPods for the hardware on these, but after looking at a few teardown videos, I decided against it. Unfortunately, the AirPods would just be too difficult to disassemble. Getting the internal driver hardware and battery out of the AirPod enclosure looks like a nightmare, and the chances of me damaging something during disassembly were just too high. The Apple AirPods are also pretty expensive for what I'm trying to do here. In the end, there were just too many negatives stacked up against using them as the donors, so I decided to find another option. After some more research, I finally found the Beats Studio Buds. The teardown videos I found of these looked much more manageable, and the internals looked to be packaged in a way better suited for this project. There's also a new version that just got released, which means I should be able to find the previous generation Beats on the cheap, which is always good. With that decision made, I'm going to put in an order for those, and I should have them in a few days. So I ordered the Beats Studio Buds. These are the previous generation ones that I found for $50 refurbished, which was a pretty good deal. You can see the box is pretty jacked up, but everything else seemed just fine about them. I did some testing, and the pairing and noise canceling features all seem to work great. I really like using refurbished and open box electronics for projects like this. It's obviously cheaper, and there's a non-zero chance these will just end up in a landfill anyway, so it's nice to put them to good use. So with them all checked and verified, it's time to tear them apart. I found some teardown videos online, and the disassembly of these is not too bad. It's still going to require a heat gun, but all in all, it's a lot easier than some of the other options out there. So first step is just to use a heat gun on low settings to separate the top and bottom of the enclosure. This took a few tries, but after cycling the heat on it for a little bit, I was able to separate everything. The majority of the components were located in the base of the assembly here. This has the battery, speaker, and Bluetooth componentry. The antenna and ambient microphones were connected by an FPC in that upper section there. The rest of this just involves working the lower components out of there without breaking anything. There's a lot of glue used in this assembly, so it just had to take some time and move slowly. But with that, you can see I've got all the components isolated out of the enclosure, so that's pretty much wrapped up. I just press fit all the FPCs all back together, and everything was good to go. I've got everything in a nice little package now that's been totally extracted from the shell that I can put back into my enclosure. Again, I'm really glad I found the Beats Studio Buds. The disassembly wasn't too bad, and everything's really nice and compact together. If I'd gone with another option, this would have been a whole lot more difficult, and getting it all fixed back into my new enclosure would have been way, way harder. Next up, I'm going to 3D scan those internal components. Once I have that 3D model, I can import it back into my CAD workflow and build my custom in-ear enclosure back around it. I'm using the same setup that I used to 3D scan in my ear castings. This is definitely hitting the lower limit of how much detail I can pull out of the RevoPoint Mini, but it should be enough to get a scan volume that I can at least build off of. I also used matte scanning spray on this as well. This EXO blue spray is pretty great. It allows most scanners to pick up a lot more detail than they could off of black or glossy surfaces. It also evaporates off whatever you applied it to in about half an hour, so it doesn't permanently mark up or damage whatever you're trying to scan in. Downside is it's super expensive at around $35 a can, but in cases like this where you're doing a small high detail object, it's totally worth it. Otherwise, the scanning process is the same as doing the ear casting scans. Basically going to just do a couple 3D scan passes on the turntable and then fuse them later on to get a complete coverage of the model. So with that done, I needed to update the design to fit the new hardware. This process took a lot longer than I expected, and I ended up having to reorient the Beats assembly a whole bunch of times to get it to fit within the form correctly. I also had to add through holes for the ambient microphones to make sure sound could still get into the enclosure. I eventually got it to a point I was pretty happy with though. You can see it here overlaid back on top of the original ear scan to see how it would fit. I also had to make it so you could get the Beats internals back inside this enclosure. With that in mind, I broke it into two major parts. I'd have the main comolded part with the lattice there, and then a cover piece I would glue in place printed in elastomeric material. That flexible, elastic 3D printed material is also kind of clear opaque, so it should have a similar look to that silicone covering the lattice at the top. That means that once everything's all glued up and assembled, it should have a pretty unified look and feel to the whole product. But otherwise, everything's looking pretty good. You can see the pass-through holes there for my ambient audio, and those are all fitting in really nicely to the whole design. So with that, I'm going to move on to the next step, which is just mirroring over those inner lattices and prepping the geometry for 3D printing. These are going to be my first ever attempt at electroplating 3D printed parts, so I was really excited to get them over to the printer. I also did some test parts along with this batch just to make sure the fit was still where I wanted it to be. These are all SLA prints done on my Form 3, so I'm just taking them off the print build platform and putting them in an IPA bath. The agitator in the IPA bath will help release any uncured resin from the outside of the parts. After a 10-minute soak, I move them over to the UV cure box for their final curing. And at that point, all the lattice parts are ready to be electroplated. This is going to be my first attempt at ever electroplating a 3D printed part. It's a process I've wanted to try for a while though, so I figured we'd give it a go for this project. I found a lot of the details on how to do this on Hendrik's 3D Print Electroplating channel, which I linked in the description below. First step in the electroplating process is to cover the 3D printed part in a conductive paint. The part's then suspended in an electrolytic solution. A metal anode is then placed in the solution along with the print. Whatever material this anode is made of is what will coat the part. In this case, I am using copper. When current's applied, the copper is deposited onto the surface of the 3D print. If everything's set up right, you'll get an even deposit of copper across the entire surface of the part. So the first thing I need to do is coat my part in a conductive paint. I'm going to be mixing my own conductive paint from a mix of acetone, pure graphite powder, and the B-side of a 5-minute epoxy. In this case, it's going to be 40 grams of acetone, 5 grams of graphite, and 1 gram of hardener. So with my conductive paint mixed up, I'm just going to load it into my airbrush and get on with spraying. I found I got the best results if I really laid the paint on pretty thick from pretty close to the model. If I sprayed from too far away, it would sort of evaporate in the air before it hit the model and not adhere correctly. After each spray pass, I'd let it dry for about an hour and then polish it down. With this paint, you have to polish the surface, otherwise it won't be conductive and the electroplating process won't work. I think if I were to do it again, I'd probably just buy an off-the-shelf copper paint. This process was really messy and took a long time between each coat. But at the end of the day, that's why I do these projects. You kind of figure out where the pitfalls are so you can do it better next time. In any case, with the part all sprayed, it's time to set up for electroplating. You can see I've got my DC power supply and my copper anodes in my electrolytic solution set up here. I just used an off-the-shelf bright copper solution for my electrolytic bath. I also got a small electric motor that'll spin the part around as it's being electroplated. This helps prevent the part from getting shadows or any other defects when it's being plated. The electroplating took about 4 hours for these parts. I have to do each of the parts separately, so this takes quite a while to get done. You can see the results are looking pretty good so far. The plating's building up pretty evenly across the entire lattice. You can see the process worked really well with these parts. It's a little matte, but I think once I buff it down, it should get a really nice bright coating to everything. So yeah, this is the first lattice part after being polished down. I just hit it with a Dremel for a couple minutes, and the shine really came through. Really couldn't be happier with these parts. Everything came out looking a lot better than I expected. All I have to do now is repeat the process on the left side part, and I'll be good to go for my co-molding. If you remember back to the original design, I'm trying to suspend the 3D printed electroplated parts in a soft skin-safe silicone. In order to do that, I'm going to use a technique called comolding. Comolding is a manufacturing technique that's used pretty frequently in consumer products and particularly home goods. You can see here I just have a common example of some scissors and a toothbrush that both have a silicone co-molded onto the main part. Products like this, I'll use the injection molding process, which I wanted to go over in detail a little bit. Injection molding is used to create most of the plastic products around us. The thermoplastic is injected into the tooling set at extremely high pressure. It's then ejected from the tool and the process is repeated. For co-molding, the same process is done where an initial plastic part is created. This plastic part is then loaded into another set of tooling where the silicone is injected. After it comes out, you have your finished co-molded part. With my design, I'm going to be doing basically the same thing. I already have my electroplated lattice, and I'm going to be suspending that in the center of the mold with pins that come off the mold walls. These pins will not only hold the part in place, but also act as through holes for letting audio for the ambient mics through. Then I'm going to be injecting my silicone through a port in the bottom, and it'll vent out through the top. If everything goes as planned, I'll end up with my lattice suspended perfectly in the center of my silicone form. Another thing I had to think about in this project was the silicone and subpart connection. Generally speaking, silicone doesn't bond very well to hard plastic parts or 3D printed components. As a result, there's usually some kind of mechanical fixture or fastener to help the silicone stay in place. If those weren't there, the silicone would just slide off the part or shift around. Fortunately, my lattice design will work really well for this. The silicone will flow through those lattice struts and should secure itself in place really well. So with the concept in place, it's time to design the sprue and venting for the mold. All the molding is going to be 3D printed out of elastomeric material, so I should be able to flex it off the part and get around any unfortunate undercuts that I have in the mold. You can see here I've drawn in the extrusions for the sprue and venting. The liquid silicone will flow in through this main extrusion here and then fill the mold cavity before exiting the vents. The venting will keep any air bubbles from forming in those high points in the mold. You can see here I've offset everything to give the mold walls the correct thickness. I've also added in some additional features to the mold. The mold is split along a part line and then connected back together with a set of bolts. This will allow me to separate the molds and remove the part after the casting is done. I've also added a lure lock connector at the top there. This is a universal connector you find on syringes. This way I can load the mixed silicone into a syringe, screw it to the top of the mold, and inject it into the cavity. It makes casting parts like this a lot cleaner and easier. So with my mold designs all done, I'm just going to export them as separate parts and then load them back into my 3D printer. These parts were some of the largest on this project and printed at a high resolution, so I think this took around 8 hours to finish up. After they came off the printer, they went through the usual IPA bath. I had to be really careful to flush out all those ports and make sure there was no resin built up inside. If I had thrown those in the UV cure box afterwards, they would have just solidified into a solid block. You can see I also printed out those flexible end covers. Those will get glued in place at the final assembly stage. So we finally have our molds and inner electroplated 3D printed part that's ready to be co-molded with the silicone. From here I'm just doing a series of dry fit tests and making sure everything's aligned properly when the molds are all sealed up. The inner part looks like it's floating perfectly off the mold walls, so I'm really happy with the way these came out. I'm also testing that lure lock and syringe setup. I used the CAD data to calculate the volume I need and ordered the correct syringes. They attach perfectly and I feel like I'm getting a really good seal, so I don't think there'll be too much overflow or leakage off the injection. Otherwise, I think we're looking good, so it's time to move on to the silicone selection. I'm going to be casting these parts in a 2-part platinum-based silicone. I decided to go with the Smooth On Sorta Clear 40. This is a 40 durometer skin-safe silicone that also has the pot life I'm looking for. The finished part should have a nice opaque finish, which should also be similar to the renderings I showed earlier. The biggest problem I'm going to run into when using a platinum-based silicone is going to be cure inhibition. Generally speaking, platinum-based silicones really don't like being cast into 3D printed SLA molds. Cure inhibition is where parts come out of the mold still feeling tacky and goopy even after they've been given plenty of time to cure. To prevent this, I'm going to be using Inhibit X, which is a solution that you can soak your molds in. It basically creates a barrier around your 3D printed molds to prevent cure inhibition and make sure you get a good part coming out. So now that I have my 3D printed molds coated with Inhibit X, I'm ready to seal it up and start casting. I've added some registration features to the mold, so everything's self-aligning and easy to put together. It's always nice having clear, translucent mold walls too. I can see that the co-molded part is really nicely aligned inside everything and not have to wonder if it's out of place. At this point, I'm good to mix my silicone and start casting this mold. The sort of clear platinum silicone takes a 10:1 mixing ratio by weight. You can see I'm just loading it into my cup here and getting it ready to go. I'm actually mixing up a little bit more than I need. The mold I'm casting into uses such a low volume of the silicone that I want to make sure I'm getting enough to get a proper mix between the A and B parts. The pot life of this silicone is 60 minutes, which means I have an hour to mix, degas, and cast this material before it starts hardening up. It's really nice because I can move slow and make sure I'm getting everything right and not feel like I have to rush through anything. I'm going to mix the two parts together for around 3 minutes, then get it into the vacuum chamber. Whenever you mix together multi-part liquids like this, you're going to be introducing a lot of air bubbles into the mixture. This becomes a pretty big issue if you're trying to cast clear or translucent parts. Those micro air bubbles will get suspended in your resin and it'll just come out looking really bad. To get around this, you can run your resin through a vacuum chamber. This will degas the mix and make it so you can get crystal clear parts. So I'm just going to drop my mixed silicone right into the vacuum chamber and kick on the compressor. From here I'm just adjusting that ball valve to increase or decrease the vacuum pressure. You can see right away the bubbles start rising out of the mixed silicone. That's all air that would have been trapped in the final casting, so you can see how important it is to do this step. Basically just releasing that valve whenever the cup's about to overflow and then re-engaging the vacuum. At a certain point enough air will have escaped and I can just leave it be for about 5 to 10 minutes. After it's all stabilized, I can just pull that release valve and open up the vacuum. You can see that finished mixture is crystal clear and ready to be poured in the mold. From here I'm just loading up my glue syringe. You can see the lure lock system just screws right onto the mold itself. It's tough to make out in the video, but you can see the silicone flowing down the sprue and into the mold. All the venting seems to be working correctly, and I can see the mold filling pretty effectively. So yeah, that's pretty much the whole casting process. I'm going to leave the syringe on the mold just in case there's any leakage or anything. Hopefully that'll just keep a constant pressure going into the mold cavity. And beyond that, I'm just going to leave it overnight, and it should be cured in the morning. I opened the mold the next day, and it looks like the part came out perfect. The silicone didn't have any cure inhibition, and that surface feels really good. The mold separated pretty well too. I think I got a little over aggressive on this backside, and it's kind of difficult to demold, but it came out okay in the end. I repeated the casting process for the other side, loaded the Beats hardware in, and glued those 3D printed caps on the base. After that, the assembly process was done for both sides. Really happy with the way these came out. The lattice structure being encapsulated in the silicone gives a really unique look. I also really like the copper detailing sort of weaving in and out of that silicone. The finished design really plays around with light and reflection in a fun and unique way that I haven't seen in too many other consumer products. Such an odd form and really fun and funky look. So with all that, I'm finally at the stage where I can test these out. It takes a little bit more effort to get them into my ear, but all in all, it's pretty easy. It's just slightly more tweaks and moves than you do with a normal pair of earbuds. Kind of have to cycle them into my ear like that in a weird way. Yeah, the fit's really good with these. I mean, obviously it should be. They're custom made for my ear, so I can't complain there at all. They're really stable, really locked in place, and yeah, I just, doesn't feel like they're going to go anywhere no matter how long I wear them, so that's fantastic. Yeah, it's actually funny. They almost fit so well, it feels like they're going to fall out in a weird way, but if I go to actually remove them, I have to really pull pretty hard to get them back out. So, Yeah, it's just really funny. It's like they feel like they're not really there, and then when you go to take them out, they really want to stay in place, which is great. Again, yeah, I feel like I could wear these a pretty long time and just not have any pressure points or soreness, and I don't think they're going to be falling out at all. So, yeah, it's just really fantastic to finally have them done and all in place and ready to go. So, yeah, it's a good place to be with the project. So yeah, now that I'm feeling good with these, it's time to move on to the second phase of the project and build out the custom charging case. Because these are obviously custom components, I can't reuse the old Beats charging case. I'll have to make my own. The sequencing on this project is really weird. I would usually design sort of the headset and the charging case at the same time just to make sure the design is sort of uniform and looking coherent. With these, I didn't want to move on to the case design until I was sure that the actual custom in-ears were totally locked down and perfect. So yeah, now that I'm at that phase, I can move on to the case design. So let's get going on that. The case teardown is going to be pretty similar to the earbud teardown in a lot of ways. I'm going to apply heat to soften up this glue and separate the internal case cover. After I get the enclosure hot enough, I can start introducing some shims to separate the top from the sidewalls here. After I get this off, I can start figuring out what's going on the internals. So it looks like there's some magnets to keep the earbuds seated and on the charging pins correctly. And then the pogo pins there are surrounded by that gray plastic. There's an FPC going down to the battery and a main PCB wedged underneath the battery there. There's a retention bracket that was easy to get out with just a couple screws. The battery, on the other hand, was really tricky. They used VHB or very high bond tape to keep it in place in the bottom of the unit, so I had to carefully pry the battery out somehow. The battery's unprotected now, so if I get a screwdriver into it or pierce the cell in any way, it'll ignite and cause a pretty bad situation. I usually keep a metal bucket or pan next to my workbench when I'm doing this sort of thing, just so I can dump it all into something and carry it outside if it goes sideways. Fortunately, this all went pretty smooth, and after a few minutes of careful work, I was able to get it out. Final lower bracket was just held in place by a final set of screws. And with that, I was able to pull out the whole bottom assembly and get the final electronic components out of the lower case. I decided I wasn't going to need this lower bracket that's connected to the main PCB as well, so I just removed it. That upper molded plastic part where the earbuds go still has one more PCB, but I'm going to leave that in place for the time being. That's the Hall sensor, which detects a magnet that's in the upper part of the lid. When you close the lid, magnetic field changes, and the unit can tell if it's open or closed. I'm going to be reusing all the magnet sensors and pogo pins in my own custom case, so I want to make sure I keep track of how those are configured and where they're located in the unit. From here I'm going to go over to Fusion 360 and start modeling in those electronic components. That way I can build my case design around the existing electronic hardware. I've already got a pretty good idea of the form I want to go after for my custom case. I'm going to do a ring in the front with a flip-up back cover to access the actual custom in-ears. I'm using some dynamic chamfer angles to reference the inner lattice found in the actual earbuds. I'm going to print these in clear and then cover them with a matte clear coat, which should let you see inside the various components and earbuds themselves. This should make for a really interesting layered visual effect with the case hinting at the inner components. I really like this concept. Earbud cases are usually a solid material and block out the actual design of the earbuds themselves. This kind of flips the idea on its head and makes you want to open the case and see the inner products. I'm also going to make that front ring a separate part and electroplate it in copper as well. This should help to visually unite the earbuds and the case. And then finally I'm going to explore using some channels that I'm going to fill in with a copper paint. I'm really not sure how that's going to look visually, but I'm excited to give it a try. With that, I think I'm looking pretty good, so I'm going to export these parts for printing. I managed to fit all the parts on a single build platform, which is always nice. I am skipping over some steps here. Really ended up not liking the proportions of the first test print I did, so this is round 2. The first print also had some issues fitting components in correctly and making sure all my tolerances were right. I integrated all those little tweaks and changes and hopefully get it right with this set. I dry fit the parts and everything looked really good this round, so I'm going to move on to electroplating that front ring. I've already hit the ring with conductive paint, and now I'm just polishing it down to get a nice smooth finish. After that, I'm just doing a resistance check using a multimeter. Generally, the lower the resistance, the better the plating will go. As I continue polishing, I start spot checking the conductivity of the part. I want to keep polishing until I get a uniform and low number on that resistance. After I'm happy with the resistance, I do a final wrap of the part in the copper wire. I can then load it into my rotating jig and get ready for electroplating. With the plating process going, you can see the copper building up on the part. I took these videos over the 4 hours of the plating process. It's really fascinating to see the copper looking like it's growing across the part. I pulled the ring out of the electroplating bath and the results came out a lot better than even the lattice parts I did earlier. Still a little rough in some areas, but this will polish off to a super bright surface. This part's also big enough to use the buffing wheel instead of the Dremel. This is great because it's a lot faster and it's a lot easier to get a uniform polish across the piece. And with that, all my electroplating parts are done. I'm really happy with how this final part came out. The finish on this is a lot better than the lattice components I did earlier. In retrospect, I wish I had done this part first and the more complex lattice components after. But what can you do? You live, you learn. I'm just glad all the electroplating's wrapped up and I can move on with the project. With all my electroplating done, all I need to do now is clean up the surface of my 3D printed case parts and then clear coat them. I want these to be an opaque clear when they're done to match the opaque silicone in the earbuds. Anytime you're going for a clear or frosted 3D printed part, you have to spend extra time cleaning up the surface. Any little minor imperfection will get amplified and be visible if you don't. This is also the time to clear out all the channels and interface areas where two parts will come together. If there's any supports or resin buildup in these channels, the covers won't seat correctly and the whole case won't close. It's really important just to double check and dry fit all your parts as you go and make sure everything is fitting and aligning right. If you remember from the CAD model, I had some channels cut out in the cover. These will give a dimensional graphic detail to the outside enclosure. I have to do this before clear coating to seal it in place. These already have a copper wire appearance, and I'm excited to see how they come out in the end. These should also reference the copper lattice design in the earbuds themselves. I wanted to make sure there was enough visual cues linking the earbuds and the case so they didn't look like two separate concepts that had just been slapped together. From here I need to prepare the rest of the electronics components from the old Beats case to be installed into my new custom case. Right here I'm trimming down the old pogo pin assemblies. I'm also going to be soldering my own leads to the back of these pins, so I don't need the screw down contacts that are built in there now. I want to get these as tiny as possible because the space for them in my case is going to be a lot smaller than in the old Beats one. With that in mind, I'm just trimming off any extra plastic on these little assemblies. Finally, I'm sanding them down and cleaning the parts up a little bit just to make sure they're ready for installation. I'm also dry fitting these parts as I go. I tend to make hole clearances and things like that a little undersized. It's always easier to remove 3D printed material than it is to add it later on. I find needle file sets to work really well for situations like this. It really helps having these to get that last little bit of fit and finish dialed in. At this point, my pins are starting to fit in just about right. It's really important that these are perfectly flush and oriented correctly. If they're recessed at all or out of alignment, the pins won't come through the case and make contact with the earbuds when they're put in, which means the earbuds won't charge, and it'll also mess up the pairing operation for the Bluetooth. In any case, now that all my electronic components are prepped, it's time to install them into the enclosure. The actual components are going to be held in place by the side covers, but I'm going to be using dabs of hot glue to keep them seated while I'm working on the assembly. If I didn't do this, all these little parts would dump out every time I flip this thing over and it would become just a nightmare to assemble. But yeah, otherwise I'm just working my way around and installing all 4 of the contact pogo pin parts right there. I also have to install the magnets into the earbud holder 3D print here. These magnets will hold the earbuds in place and press them against the pogo pins to make sure they're charging. It'll also keep them from just tumbling out whenever I open the case up during normal use. Fortunately, the neodymium magnets in the original Beats enclosure are strong enough to hold my new design in place, so I can just repurpose everything. At this point, I need to rewire all the components back together. This is actually a pretty straightforward step. I'm just soldering leads from the pogo pins back to the PCB. I once again got really lucky with the electronics design in the Beats. All these pogo pins have really long contact patches on their back, so I can just build up a bead of solder and then attach my leads. the design had been different in any way, it might have been a lot more difficult to do this soldering operation, or things would have been much more fragile once it was all assembled. But yeah, I really can't complain on this one. It's all coming together really easily. With the leads all soldered in, I'm just adding some shortcuts of heat shrink tubing. This will keep the wires organized and easier to manage once I put all the parts back together. And then to wrap up this stage, I've got to solder the leads back into the PCB. I had to be really careful here that I was getting the correct leads going back to the correct terminal. If I had reversed these, I could have pretty easily permanently damaged the hardware. But yeah, after triple checking my wiring diagram, I started soldering these back in place. These are actually screw-down terminals, which make them, again, really easy for soldering. From here I need to load the USB controller and battery from the Beats into the base of my custom enclosure. My new design actually has a lot more space than the Beats case, so getting this in here wasn't too tricky. Took a little bit of work to get it aligned correctly, but then it seated in just fine. I designed in a set of holes to receive these plastic screws. That way I can just screw the PCB back in place and everything stays locked down pretty well. These are really important to keep the PCB from shifting backwards when you plug the charging cable back in. And next up, I'm just going to glue the main earbud holder back in place into the lower assembly. I have to make sure this flex print connector aligns right, but everything's looking good so far. I'm just going to use a couple dabs of CA glue to make sure this is locked down and good to move on. At this stage, I'm adding a bead of CA glue along the left and right cover panels. This will keep these locked into their channels when everything's done and assembled. The last bit of gluing is around the electroplated front component. This is designed to stay in place mechanically, so if I pull forward on it, it shouldn't pop out even if there's not too much glue in there. This is really nice because it can just put a few dabs of CA glue on the inner lip here and it'll keep locked right down. I'm going to just slide a rubber band around the whole thing and leave it for a couple hours to make sure everything's fully dried. Final step is just to drop a brass pin in between the lid and main enclosure. This will allow the entire lid to pivot up and down, and that should finish the entire assembly. So yeah, just can't be happier with how this came out. This was such a fun project, really pushed my design abilities, and I got to learn some new manufacturing techniques along the way, which is always amazing. Hey, thanks again for coming along on this one. As always, it's a big help if you like and subscribe to support the channel. Hope to see you on the next project.